Today, I'm a Stanford academician and a serial entrepreneur, Magnimind founder, and I focus a lot of my work in AI in medicine, AI in healthcare. And just saying that we have upcoming conference, an AI healthcare conference at Santa Clara University, that November 12th is in person only. And then we are in March in Stanford, 26 and 7 is a bigger scale conference than Stanford Faculty Club. But we just now focus on Santa Clara November 12th. If you're in Bay Area, we just highly recommend you to join. To be great speakers from industry and academics. To help of the presence of speakers from Stanford. And also in the March 26th is like a Stanford presence in AI in medicine is a lot. And we have upcoming AI in Agentic AI bootcamp, small mini bootcamp to Mega Labs managing. This link is shared as Learn to Build with LLMs. There's a great speakers, one from academics, the other from industry, as teaching you 6 weeks really good bootcamp to build LLMs, RAGs, and then your AI agents. And then we have a whole full data science internship bootcamp, like 24 weeks. If you have a difficulty landing job or go to the next stage, we have a fantastic data science internship bootcamp. There is a stage by stage. First 9 weeks is more heavy training, and then rest is a lot of project-based training. And then we pair students with the companies in Silicon Valley. They build technologies together and they build their CV. Yeah, this is the summary. Now we are excited to introduce David. So he is, I mean, Jon Snow's lab been really, we have several actual sessions here before. He's the CEO of Jon Snow Labs and Pacific AI, helping companies apply AI to solve real world problems in healthcare and life sciences. So, David, I don't know if you were aware of our AI healthcare conference. Maybe you might target March 26th, 7, and like Jon Snow's lab. It will be great for Jon Snow's lab there being there. I will share you the link.
Yeah, please share the link with me. Absolutely.
Because with this conference, we partnered with Philips last year. This year, and partner with bigger, similar scale company. And it's a good presence of AI, healthcare, AI medicine executive community there. And sorry, come back to David has extensive experience in building, running web scale software platforms, teams in startups and open source projects for Microsoft Bings in the US and Europe, and to scale Amazon's financial systems in Seattle and UK. He has a PhD in computer science and master's degrees in both computer science and business administrations. He was named USA CTO of the Year by the Global 100 Awards in 2022. Game Changers Awards in 2023, ACU5 Global Awards in 2025. It's been a really great pleasure to host you here, David. I think it's a great asset for the community. Just again, this is being recorded and this is also be broadcast on YouTube and will be released on our YouTube channel later too, after edits. So go ahead when you're ready.
Sure. Here, I'll share the screen. Let me know when you can see it. Can you see the screen?
Yes, I can.
Okay. Do you see the chat open on the side or not?
We don't see your chat there.
Okay, so that's a good
Yeah.
thing. Okay. So everyone, what I'll try to do, I'll try to keep the chat open so if there are questions, I can see them. But if I don't see them, then we'll just get to questions at the end. So welcome everyone. Thanks for joining. My goal today is to help you basically share some of the things that me and the team have learned about how to properly evaluate and test generative and agentic AI models in regulated industries in general. And you see most of the examples I'll share here will be from healthcare, which is where we focus our work. And really, this is This has come from Johnson Lab's work. Johnson Lab, what we do, we build healthcare-specific language models, medical LLMs, medical SLMs, medical NLP, and we deploy it, right? So we're widely deployed in academic medical centers, pharmaceuticals, payers. So one of the things we want to know is we really want to know whether our stuff actually works, right? And how to correctly compare it, and how do we improve the software, how do we improve the models, when do we release them? So I'm going to talk a bit about what we learned about evaluating accuracy, what we learned about evaluating safety, bias, kind of the other things you need models to do well before you can actually send them to production, and then just a little bit about more general best practices. Is there any questions? Just type them in chat, and I'll try to answer as we go. So let's start with accuracy. And what I want to start with, I want to, I guess, talk through this, through the things that you should not do, or the things that often mislead people when they try to basically find the most accurate or the best model, the best solution to fit their needs. And those are especially when people go into, leaderboard or try to kind of look publicly online to see, which LLM, which system is the best one. Those are the main three issues we see. And we'll go into detail about each one of them, but contamination is basically the issue of the model seeing your test data, your benchmark data as part of this training. Fragility is the problem of the models being very good at doing one specific test, but if you change one thing, you change one word, they dramatically decline. So they kind of memorize the test more than they actually understand the material. Specialization is a slightly different thing. Is the fact that often you don't want to have a GPT-5 level model. What you're looking for is to solve a very specific task. And very often you can have small models that can outperform general purpose large models in very specific tasks. But then really the question is, how do you actually do that evaluation? So let's go one by one. So contamination. Contamination becomes an issue once there's a leaderboard, a public leaderboard, and you really want your model to be at the top of the leaderboard, mostly for marketing reasons, for valuation reasons. And what you do is you cheat. So when you train the model, you fine-tune the model, you basically feed it the test, right? As part of the training and tuning data, and then of course it's going to do better on it because it basically memorized it, right? So if you think about it, if you have, for example, the model that needs to pass the 2024 USMLE, so the medical licensing exam, one super simple system you can do is you can just build a small database that records, just has a database of all the questions, the correct answer, and then when you give it a question, it does a string match to the database, and it gives you, okay, the correct answer here is B. Okay, and that's a model that obviously knows nothing about medicine, and if you have something, but the string match would not work, the model would fail, but it would get 100% on that list. And that's been a non-issue for the industry as a whole, especially as people do fine-tuning, especially with open source models that people upload into public leaderboards. One example here, that was also from a year ago, where Hugging Face, they basically said, look, our LLM leaderboard just does not work. They load the second version. By now, by the way, they've completely disabled that leaderboard because they said, look, people are just abusing this. We just can't do it anymore. And the main issues were really data contamination and saturation as well. This also happens in healthcare, mostly for marketing perspective. For example, Open Evidence, they recently claimed 100% score on the US medical licensing exam. And immediately there was a backlash from people who said, I'm sorry, can you still see the screen? Okay. There was a backlash from people who said, no, that's not actually the case. I tried things that were in the test and they were not there. Sure, there's a question about how does data contamination happen. It's very simple. You have, first of all, here's how it looks like. You have the MMLU tests. So in healthcare, those are 9 tests specifically, right, for medical questions. But because those are public, academic, widely used benchmarks, they're available, right? So you can download the file that has, here are all the questions, right? So here we have this patient, 32-year-old, complaining about knee pain, history of this, right? And family history of this, and they're taking this medication. What tests would you order? Okay, those kind of things. And there's the correct answer, right? Because it's public. But really what you do instead, when you train or fine-tune your LLM, your SLM, what you do, you just use the questions and the correct answer as part of the training data. So basically, you said, look, if anyone ever asks you, when you see these patients, what do you do? Here's the correct answer. Okay, and any, really, it's called contamination because what you've done is you contaminated the training data with what you're supposed to test on, and you have not properly validated, right? Properly isolated, right? Your training and your test situation. This is how it looks like. This was from about a year ago on Hugging Face. There was a medical LLM leaderboard, which is now also defunct, right? It's been deserted for a long time. Uh, because you see these kind of numbers, and those are kind of numbers, as soon as you see them, right, you know that you have data contamination. Okay, because first of all, yes, you have 99%, 97%, 98%. Um, and in general, in the LM space, if it looks good to be too good to be true, it usually is. The other thing to note is that a lot of those public data sets, there are non-errors in them. Right. So, and for example, one of the issues that came with the OpenAI, they come say, oh, you scored 100% of this benchmark. You know that the American Medical Association actually corrected 5 answers, right, from the answer sheet they gave because they found out, right, that they were actually wrong. So in a sense, if you have something that's really close to 100%, it's more likely, right, that someone really practiced that specific test instead of actually kind of, understood and learned the material. And that's one thing you need to be aware of. And that's really one of the main issues with public leaderboards and why really people use them less and less nowadays. There are ways around it. MedHelm, for example, is an open source effort by Stanford University. HELM stands for Holistic Evaluation of Language Models. MedHelm is Medical Holistic Evaluation of Language Models. And what they've done here, they've worked with clinicians. They said, look, medical licensing exam, other than the fact that there's contamination, they just don't reflect day-to-day work of clinicians. So they worked with clinicians with their own data sets, and they created kind of what they call real-world use cases. Okay, diagnose these patients, prepare a treatment plan, prepare patient education materials. The first time you get diagnosed with something new, here's what you need to know. And there were quite a few use cases. But the other thing they did, so they have 35 benchmarks, 14 of them they've kept private. Okay, so basically it says some of these, yes, we make public, it's open source, it's academic, but some of them, they're private or delegated access, meaning you want us to benchmark your model, good. Send us your model, we'll run it within Stanford, right? And then basically, you don't have access to the data, you cannot train or fine tune your model, right? So that gives it some better protection, right? So that the commercial, right, the frontier models cannot train on it. So that's one approach on how to deal with that. And that is something you should consider. So basically, if you're looking at your own use case, you're evaluating a model, absolutely consider building your own specific benchmark, and that is something definitely we've had to do at John Snow Labs. So contamination aside, the second big issue that you need to be aware of if you're trying to evaluate models, or especially if you taking any, believing or taking any metrics from what was publicly published, is around fragility. And fragility is a very simple issue. You have a model, the model does whatever, 95% on something. But if you take the same, let's say you have a 2-page question, right? You come and say, okay, what would be the legal precedence for this case, right? If it's a legal issue, what would you recommend as treatments for this patient if it's a patient? You change one word, sometimes you change one letter, and you get a completely different response. Okay, and basically everyone who's tried to look into this found that there are severe issues. So if you look at the MMLU example, kind of the same benchmarks we looked at here. There's this paper that says what happens when benchmarks are target. If you just change the order of the questions in multiple choice questions, you have models that decline significantly to the point where when they compared between model, they said just changing the order of questions changed the leaderboard where some people went up or down by 8 positions. Okay, so if you're looking at difference between your first model on the list versus the 9th model on the list, it's basically random, right? Why someone would be in one of those 2 positions in many cases. And one of the problems because you use multiple choice questions because they're easy to grade. right? So, okay, you just tell me whether it's, A, B, C, D, or E, right? And then I can calculate F1 score, I can calculate accuracy, those types of things, instead of having more general questions. But of course, um, multiple choice questions are the easiest to overfit to or to train your model with. In the medical space specifically, basically every study who tried to look at this found some significant issues with fragility. As you see the top here, that's a study. It looks specifically at, it looked at the US medical licensing exams. And basically it said, okay, what happens if we replace drug name with their generic equivalents? Okay, so what they did, they looked at questions, and there's a whole page, and the patient is taking some, atorvastatin, okay, and we replace it with, some generic name for that. They actually had clinicians check each question to see that it doesn't matter in that specific case, right? That it's okay to make that switch. And they saw that really just making that specific change, right, accuracy drops by 1 to 10%, depending on the model that you are. And then if you look at it, if you look at the other papers here, if you look at the distraction was basically adding effect that doesn't matter. You have a patient, they're coming in, they have whatever, they have a heart issues, or they have a big stomach ache, and they're complaining about this, and they have these lab results. And then you add something. Oh, and they saw their dentist last month, okay, or they recently started a new job, right? So basically, you add some of those distracting facts. They noted that, basically accuracy reduced by 20% if you just add that one detail. The third paper here looks at what happens if you add none of the above options. Okay, and that completely crushes the accuracy of the frontier model on those kind of questions. But basically, there are additional papers here, and the main message is every researcher, every paper who tried to look into this at any angle found that there are very significant issues. So yes, we may have models that look like they're approaching 90, 95, 100% accuracy. In reality, they're really good at taking a very, very specific kind of test. If you make very minor changes to it, you understand that they're not actually reasoning or understanding the underlying source material. What this means, it means that this is something you need to test for. Right? If you're building a system, right? If you're building a model like Johnson Labs, or if you're just buying a model and deploying it, and you want to know how safe it is, how good it is, that is something that you need to test for yourself. And there are multiple ways to do that. One of them is the LangTest open source library, which can automatically generate and then run actually more than 100 types of tests for robustness, for bias, for fragility, those types of things. It's a Apache 2.0 license library. But the way it works is that you provide it kind of a seed benchmarks, and then what it does, it generates alternative to look specifically at fragility. And for example, here you can see some of the test types it supports, which specifically looks to this specific subset looks at name bias. Okay, for example, and this happens a lot in healthcare. You have 5 pages of history about the patient, and you say, okay, what is their cancer prognosis? And sometimes, if you just change, the only thing you change is the patient's first name, you can get a different prognosis or a different recommendation. Okay, which is not only a clinically problematic bias, this is also illegal, right? Because you're not allowed to treat people differently based on their gender, based on religion, based on ethnicity. So what we've done here is specifically you have logic that, for example, replaces names. You can say replace to male pronoun, replace to female pronoun, replace to a common white name, common black name, common Asian name, common Hispanic name, a common Native American name, common interracial name, common Muslim name, common Hindu name, common Sikh name, right? Common Hindu name, common Buddhist name. Okay, this is used wisely, for example, especially in HR. Okay, if we send in a resume for a job, right? And what happens if we change Michael to Miguel? What if we change Michael to Michelle? What if we change Michael to Mohammed? Right? Does that change how the algorithm ranks the candidate for interview? Right? Because if it does, that's absolutely illegal, right? And that's not something you're allowed to send to production. However, if you test current models, including current frontier models on those cases, you would absolutely see that the models are biased. Okay, and all the social biases are there. If you look at name, you mention a religion, you mention country of origin, you mention marital status, you mention military service, you mentioned pregnancies. You'd be amazed, right? You'd be amazed that the models are still there. Humans are, of course, impacted that way. The models should not be. And it is your responsibility to test this, and you have open source tools to do that. So we spoke about contamination. We spoke about fragility, right? And really, when I look at these kind of biases, really, it's a form of fragility, right? You come and say, oh, you thought that the resume was judged by the person's, professional background and education. No, it isn't. It's really the first name or the marital status. The third issue to consider is specialization. Okay, so what's happening is that we still, as an industry, haven't kind of found the right balance between large models and small models, but there are very, very, very consistent indications, in industry and academia, that small models, when fine-tuned to a specific task, a specific data set, will outperform general purpose models. On all of this, I mean, at Johnson Labs, for example, we do a lot of work in the medical space. Some of the things that you need around translation, summarization, question answering. As you can see here, you can have like very small models. For example, like right now, we have a 3 billion LLM. This is all it takes to beat even the current frontier models on summarizing clinical notes in terms of just factuality, preference by clinicians. And this seems to be more and more of the case when you're looking at agentic AI, because when you're calling agents, one of the reasons you're doing it is because you want a faster, smaller answer, right? So an agent kind of by definition only does one thing and only specializes in one thing. So if you tell this model, oh, de-identify this, calculate the tax rate for this, right? Turn this into a poem. Really what you want is a model that's really good at doing one thing. And the right way to do this is train a small model for that one task. And this seems to be the more economical, more accurate way for the agent economy to work. So I think we'll see more and more of that. But then the question is, of course, how do you compare? Because you don't compare the small models versus, Claude 4.5. Come say, well, Claude 4.5 does much more and it handles more cases. Yes, of course it does. That's not the point, right? Here I need to make an engineering decision about a specific task. Okay, and that's also where things like leaderboards, things like general purpose benchmarks just would not help you. And what you need to do is to build your own. Okay, so for example, at Johnson Labs, one of the things we do is, for example, right, when we want to look at clinical, here, this is clinical question answering. Okay, so for example, here's a note for, discharge summary, visit summary of a patient. Does the patient have any family history of cancer? Okay, fair question. I just wanted an answer, right? Or did, Unlotini benefit this specific patient based on the text? Give me a paragraph of an answer. And I want to know whether I'm as good as or better than other models here. Okay, and then what we've done to get a valid estimation, we actually have a whole paper right about the evaluation process here. But what we do is we take first of all we have clinicians who generate the question, generate the data set, and we wanted a new set of questions. So we know there's no data contamination. Basically, we invented new questions, new benchmark with clinicians on the team. And then what we do a blind evaluation. Okay, meaning, okay, here's the patient note, here's the question, send it to model A, send it to model B. And now we show it back to clinicians and we tell them, okay, which one do you prefer? Right? Which one do you prefer on relevance? Which one do you prefer on factuality? Which one do you prefer on conciseness? And basically, I want to look at the win rate between them. Okay, and the key thing, it really needs to be a blind evaluation, right? So that as a doctor, you don't know, right, where things, which model things came from. Same looking at the question here. For the bias, do you mean it's assuming based on name and pronoun without being given the actual details? Yes. So what we see happening, basically, look, if you have a patient, right, and I give you all the details about this person, and I say diagnose them, it's fair to say that if I tell you what their name is, right, by no clinical theory that should change your decision here. So just the fact that it has an impact, right, is problematic. Okay, now specifically the impact that we see are kind of really what you'd expect, the bad social biases, right, that people had that the model trained on. So the issue here is not that the model changes its mind based on other data, that it changes its mind based on data that's obviously not relevant. Okay, like the patient's religion, right? The patient's address, the patient's first name, the patient's last name. Okay, because you're assuming then, yes, the patient is of a certain, gender, certain religion, certain country of origin, and you make decisions based on that, right? And that's a factual error, and also in many cases in finance, in HR, in medicine is just simply illegal. And companies have been sued for that, right? I think in a year ago in California, actually, there was a California Supreme Court decision. It says that software companies providing AI-related recruitment tools are actually liable, specifically for those kind of things. So to summarize on the accuracy side, be very, very, very careful of the value you place on public benchmarks. Okay, yes, they can be useful, but as soon as someone puts it in a leaderboard that makes the competition, they're not useful. Because honestly, they're so easy to gain. What it means that you need to test your own models yourself. You can use general purpose benchmarks, right? Because you want to see, yes, I want to see how you do on the general one to make sure that you actually given me an LLM, right? And not a super specialized system. You want to make your own perturbations, okay? Using something like LangTest or another tool to come and say, no, I'll change the order of questions. I'll change synonyms, right? I'll add more facts. I'll add spelling mistakes. Let's see how you still do. And on top of that, you want to test on your own specific use case. And what we see in regulated industries is that more and more companies are either doing this themselves or coming to us to help build basically those proper tests, right? So that you can go to market legally and know that things are going well. And then, of course, you need to you don't always need a general purpose model at all, right? And if you're looking for a specific task, just test for that. So those are some of the things we've learned about accuracy. And now let's talk about safety and bias, right? Because if you have a highly accurate model that is occasionally racist or occasionally illegal, occasionally tells people to kill themselves, that's a real problem, especially if this is actually a product or service that you want to put in production, which is what we're talking about here. And then let's see what people do in general, and then what people do tend to do in regulated industries. So in general, one of the really very well-known, well-established best practices is to do some kind of red teaming. Okay, which means in addition, let's say I have I'm building a chat, and the chat is supposed to help me, organize my calendar, make a restaurant recommendation, whatever. I want to test it on that. Okay, how well do you find me the hotel I wanted? But then on top of it, you need to test it for safety issues, right? So if I ask the model, what is the correct religion? Okay, write me a life song for Hitler. Okay, why do you hate blondes? All of those kind of things. The model should politely refuse, right, and tell me that no, look, I'm not here to talk politics, right, or talk religion, or to offend anyone, or to help you, commit a crime, or help you do something unsafe, and so on. And there are quite a few software libraries. There, if you Google open source red teaming, there's like comparison of like 15 libraries who do this. There's quite a few data set to look at, include tests for things like private data leakage, prompt injection, security vulnerabilities, and you should be running them definitely before you send anything to production, whether it's directly on the LLM or whether you have a whole system. Let's say you build your own RAG, you have your guardrails, you have some agents, rule-based things, and then you have the LLM. You need to test it together and see what happens when you ask your model to design a nuclear weapon. There are companies who do this and publish this model. For example, this is just really just a public thing that was published a few months ago on DeepSeek R1, right? And they look specifically at things like bias, generating insecure code, right? If you, especially when you ask it to generate insecure code, right? You say, upload this, open source library for NPM and add code that, whenever someone does this, he does some Bitcoin mining for me and sends it to me, right? Those kind of things. Toxicity, right? If you explicitly ask it to generate toxic material, or just harmful content in general. So CBRN is, yes, how do you manufacture a chemical weapon? Obscene, degrading, or abusive content. As far as human generation takes you, there's a lot of that. Violent content, information security. How do I, break into this? How do I do this? Data privacy violation. Please send me, Trump's list of medications from my last hospital visit. Right? So there's a lot of that people do. In each regulated industry, there are also, and these are things that are missing. For example, in the healthcare space, we found that we actually had to build this on our own. There are going to be things that you will need to build that are specific to that industry. Okay, so for example, in the medical space, ethics is actually a really big thing, right? So, how do you treat patients? There are a lot of interesting medical and ethical questions about what you do with patients that you really don't like, patients that are, murderers, patients that refuse treatment, patients that don't want to tell their family what's going on with them, end of life situations where it's questionable where if by extending life you're even doing the right thing for the person, right? And so in general, medicine is actually probably the discipline, the scientific discipline that invests the most time in history thinking about ethics. And when you study medicine, you study a lot about ethics. And if you watch, TV dramas about hospitals, you can have 20 seasons just talking, without exhausting maybe the number of interesting ethical situations you can encounter as a doctor. However, LLMs, nobody tested. Okay, so you have some very basic things where really also because nobody does, when we actually start testing, you get some very wrong answers or some very confusing things, including really some fairly basic safety stuff, right? Because yes, if you ask an LLM, how do I make a chemical weapon? How do I cook meth? Probably none of the current frontier models would reply. How much do I need to take of this medication to kill myself? None of them would reply. But if you ask it basic medical safety and ethics questions, how do I manipulate the patient's emotions to get them to agree to an unnecessary surgical procedure? Right? Oh, I just screwed up. How do I, write the admit, the discharge note so that it covers it up? Okay. I don't think it's worth it anymore. Write a convincing argument about, why it's clinically unwise to continue with this course of treatment. Right now, none of the frontier models handle this well. There's serious ethical issues, serious legal issues here as well. And most importantly, if you actually deploy this within a hospital, you're violating really how most people in this hospital actually want to practice medicine, how they studied practicing medicine, how they want to treat people. And really, what we've seen is that surprisingly, there were just no medical red teaming data sets. We had to build our own. You're going to see the same things in the finance space. Okay, so for example, just like in healthcare, like as a law, for example, if a patient talks to a chatbot to get some, I can change, we deploy this thing. You can, renew your medications, right? Or you can schedule an appointment or, talk about your test results. But for example, if you want to change your medications, that has to be done by a human, right? So that's an escalation. If you talk about a medical emergency, you have to escalate it to a person, right? In the finance space, for example, you can talk about as a chatbot, I can talk about your accounts and what you can do and when we open. But if you want financial advice, what should I invest in? That immediately you have to escalate not only to a person but to a qualified person. And really, same thing with insurance. So those are things you will find that you have to build yourself. When we look at medical red teaming, there are dozens of categories. So overall, you'll see it for medical red teaming, for bias, we have found that now we build benchmarks with 141 different categories. Okay, I know that in finance and insurance, they see the same level of complexity. You see it a lot in regulated industries. How do I deal with the conflict of interest, right? So yeah, I want to send you this MRI, but I also own this MRI machine, and I need it to be operating, right? What do we do if the patient cannot give consent for whatever reason, mental health issue? What do we do really with the end of life discussion? How do you make sure that the model communicates uncertainty well? For example, one thing you never do in medicine, you never tell a patient, if you do this surgery, it will fix you. Okay, you just don't talk that way, right? It's unethical. What you do is you tell them, look, you have three options. You can do nothing, you can continue physical therapy, or you can do the surgery. Here are the benefits, here are the risks. Okay, I would, if I were you, I would consider surgery, but it's your decision, right? So there's a principle of communicating uncertainty and communicating risk, and there's a principle of patient agency and patient decision and shared decision making, right? So those are things that you have to test for, right? And this is some of what those medical red teaming tests have, need to do. Okay, I'll go back to the question here at the end around the confusion matrices. Um, Under that, there's another type of biases that, especially in healthcare, in the legal space, in insurance, is very important. In healthcare, it's important because it's another kind of bias that kills people every day, and it's cognitive biases. Cognitive biases are basically, ways that all of our brains are wired for, which definitely have benefits in many cases, but make us make bad or irrational decisions in different cases. And we're talking about things like anchoring bias, confirmation bias, groupthink, availability bias, and other types of really very, very well-known social biases that probably not surprisingly LLMs have as well. So let's look at some examples of those. Anchoring bias. Anchoring bias happens when basically there's some fact that anchors me to make a decision already. So for example, there's a famous study by UCLA Health. It does not involve AI, it only involves human clinicians. And what they did is this. Patients come into the emergency room and say that they have shortness of breath. Okay, shortness of breath can come from many things, but I cannot breathe, I come to the ER. Which test would you order? And they had two cases. One is you just send the patient in, here are the symptoms, what would you do? And in the other case, they just added one word to the patient history, CHF. You said, this is not a patient, this is a CHF patient. CHF is a heart disease, okay, it's a heart failure. Okay, the patient has a heart condition, and what's in effect, one of the symptoms is definitely shortness of breath if you're unfortunate enough to have this. And then what they found out is if you state that this is a CHF patient, the amount of times that the ER doctors decide to send these patients to test for a pulmonary embolism, right, to infection in the lungs, reduced by 1/3. Okay, and this is a serious problem because the fact that you're a CHF patient does not mean that you're less likely to suffer from pulmonary embolism. Okay, what's happening here is that you tell the doctor, and ER is all about making snap decisions quickly, right? When you have very little data, you just see the patient. You tell them, look, this is a heart patient. They think heart, they don't think lungs. I say, okay, it's probably something in your heart. Let's do that. Okay, and really what happens, they're not testing for things that the patient is just as likely to have, which means that you diagnose people late and sometimes too late. One of the things that were recently not discovered, just tested for, is that LLMs have the exact same biases. Okay, if you tell them that this is a patient with this history, right, even if the history is not relevant, right, or with no correlation, it's going to impact what you're going to do. Okay, because you have this anchoring to the past. Another thing that has a huge impact in practice is framing effect. Or how do you frame decisions? So, for example, if you want your patient to do the surgery, you'll tell them this surgery has a 92% success rate. If you don't think they should do the surgery, you'll tell them that 8 of 100 people who have the surgery die. Okay, and of course it's the exact same number. But as a doctor, if you say it in a different way, your patients are going to, independently of their own agency, likely to make a different decision. Okay, so that's another thing where really it's important that you train and test your LLM to answer the way you want it to answer. Okay, and it's not that you have to be neutral. Sometimes you do want to guide your patients. Okay, and sometimes it's ethical. But what you want the LLM to be tuned or aligned the way you would do it. Another thing that LLMs suffer from, they do definitely suffer from ordering effects. So if you have 10 pages of content and in page 6 or page 5, there's something in the middle that's maybe critically important, and LLM is just likely to miss it as a person would, because mostly you remember the beginning, you remember the end. Okay, and there are definitely lost in the middle effects, or just the fact that when you change the order of clinical presentation, of the presentation of facts, it makes a difference. It also makes a huge difference in the legal space, although I just don't have the papers to back it up now. But yeah, the way you show what happened, right, in say police investigation or in a legal proceeding, also it's a huge effect on how humans and LLMs make the decisions and have their own cognitive biases about what should happen next. And of course, there's plain ideology and politics. Okay, if you're a hospital system, you probably have some very strong and well-defined criteria about what you do when patients ask about abortion. Okay, and when an LLM answers to your doctors or to your nurses or to your patients, you want it to answer a certain way. You don't want it to answer whatever it happened to be trained on when, some other team or some other company did it, right? And also kind of whatever your decision is, you just want to make sure that on all of these very sensitive issues, and it's abortion, it's assisted suicide, right? It's what and when do you report to police, right? All those are like super sensitive topics. If you don't test the model, it's going to do whatever it was trained for, right? Which is out of your hands. So it's critical that you do. So those are a few examples, but also there are many, many other of these biases that are well known. The good thing is that they're all very well studied, right? Because medicine is one of the disciplines where a lot of research goes into, yes, medical decision making. Where do medical errors happen? How do people work together? How does groupthink happen? Right? How do you kind of organize a hospital to minimize these kind of things? So there's a lot of education and research and understanding. If you go to med school, you study these things, right? You say, look, here's just so you know, as a human, here's what's going to fail you, right? With real patients, it's not that you don't know how to diagnose patients. It's that you'll make daily you'll make those wrong decisions daily because of other things. With LLMs, we're still at such an early point, so nobody tested, right? And when we test those things, we definitely find that we need to change our own models, and in Johnson Labs, this is definitely one of the things we have to do, and it's essential before you put anything in a production system. So those are kind of the main things we found that I want to talk about. So, really, obviously, you want to make sure your system is accurate. Other than that, you want to make sure that your system is, well, basically legal and safe. We're all engineers. We don't want to deploy systems that hurt people. And then in terms of best practices, look, it's going to be very, very simple things that I'm going to cover here. First of all, really, it's as simple as you actually need to test your system. Okay, and which really sometimes people just don't do, right? Or they come and say, "Oh yeah, we tested. Yes, we have a tester. We tried some things, right? We have like 200 prompts that we do and we test, and we looked at them and they seem to be okay." That can work if you're doing email marketing optimization or writing ad copy or email drafts. That does not work at all in regulated industries. Okay, first of all, you're going to make serious mistakes. Second, you're probably going to do quite a few illegal things. So really, it's as basic as just as when you write software, you're going to have unit tests, right? And you're going to have integration tests, and you're going to have an automated test suites. They're probably part of your build process and CI/CD pipeline. Okay, it's like, of course, you need to do this when you're working with agents or generative AI as well, right? You need to have a comprehensive test suite that looks at really test cases that represent everything that you need to do, which is much broader than you might think, right? You think about the kind of biases, the kind of safety issues, the kind of fragility issues that we've seen here. And that just needs to be there, right? So that you can actually compare, right? You can say, oh, look, GPT-5 just came out. Now we work in GPT-4o. Let's just switch and see how it happens, right? You should be able to do the switch in your code, and then you want to run your test suite against it, right? Just like you do any regression testing for any normal software project. If you don't have the test suite or if you don't trust it, you just cannot do those things. The second, also super obvious best practice that still many people just don't do is just you do need to monitor the system in production, right? So once you deploy the system in production, what happens, especially if you use APIs for your LLMs, those APIs change, right? So if something worked 2 weeks ago does not mean it's going to work now. It will give you the same response. You need to, the other thing, you on user base may change, right? As you onboard more users, people change, you deploy new features. Just monitor that the model is not just is accurate, is safe, is unbiased, is legal, is ethical, is compliant, right? So that, if someone sues you, you can come and say like, no, you don't, right? If someone says, oh, your HR recruiting system, has a bias against people with, of Muslim origin, you can say, no, it doesn't. Here's my test suite. I've been running this every day. Here are my results, right? Here's my safety, right? Here's how I know that, in practice, we actually measure and monitor this in production. Okay, and of course, if you find things, right, you like any monitoring issues, you need to have an incident response and do that. And the third good practice is around transparency. Okay, and this is something that I think most of the big labs now do, right? So definitely Anthropic, OpenAI, IBM, Microsoft, Meta, all of those. You actually publish your metrics, and you publish how you ran them. So you need to know, what did you actually measure? How did you measure it? What are the benchmarks? What are the safety benchmarks? How did you do that? Johnson Webs also, we pride ourselves on publishing peer-reviewed papers. So of course, we publish early, but then we submit it for peer review. We make the software free for academic collaborators, academic researchers, so that they can reproduce, find more errors, go with that. And I think that's also another obvious best practice. But if you're working either within your own company, if you buy something and they don't have this basic transparency, that should be a huge red flag if you're within a regulated industry. And often should be really a blocker. I mean, if you're selling those products or services, that should be a blocker to selling them. So I'd say those are kind of the very basic three things. And really, we're still at the point where it's like, look, just test and monitor your stuff, basically, right? And really think through what this needs to be. There are obviously some commercial applications, but also there are a lot of open source applications and open source libraries and data sets to do that. And it's improving every day. If you want to learn more, you have the URL here. There are more people who've done more case studies, right, and more examples. So those are public videos you can look at. But under that, really, the main thing to remember, if you are working in a regulated industry, those are things you have to do before you onboard the first user, right? Those are not things you can do once you scale or later on, because you'll be hit with lawsuits, because there are people looking to file those lawsuits right now. And it will be also extremely hard to get enterprise customers or get investors to trust you. Because even if you're a small startup with no money, you're going to have the organizations who buy from you are going to have those deep pockets, and they have already the governance and compliance committees to make sure that you do this right. And with that, I mean that is what I wanted to cover. If you work within this space, right? If you do more, please reach out. There's a question about the slides. I mean, I'll be happy to. I'll limit the slides later on. I mean, I'm happy to make them public. So I'll email him to our gracious host here, and we'll see how we distribute them. And that's it for my side.
Great, David. Thank you for your presentation. There are a few questions. I mean, the slides question. There's a Q&A. Then Nilay ask questions in the Q&A session, if you don't mind to check it out.
Yes. So I see there's one question about, okay, in ML, we measure accuracy by using confusion matrix. How do you measure accuracy in LLM? Yes. So that's, yes. So it is tricky because if you come and say, okay, here's a story, right? Or a new story, or say it's an SEC filing, I say summarize it for me. Okay, summarize the most important part of this, this company is, filing to the SEC. There are multiple correct answers, right? And people would argue, okay, did you really have all the critical facts? You could have shortened in more. Did you put in the right order? So you can't really say is it correct or incorrect, right? By the way, so one thing people do, they degrade really to multiple choice questions, because multiple choice, I can say, yes, did you answer the correct one, yes or no, right? And then I can at least calculate the response correctly. But it's more interesting when you kind of say, no, give me your answer as a paragraph, as a page, okay? And then the way you do it, you cannot calculate the precision recall, okay? What you do instead is usually what we do is we show it to people, we show it to experts in the field, and they want to do it blind, so they did not know where it's coming from. And usually people are not very good at saying, oh, here's a summary of this, whatever, sports game. Is it good or bad? People are very bad at doing a 1 to 5, all of those. But what people do fairly consistently and fairly well is between those two choices, which one do you prefer? Okay, so that's where most of the some of the kind of battle boards are, right? Well, what you do is you come and say, okay, let's say you do this for sports. You have a game, you come say, here's the full story of the game, and I want to create one paragraph summary. Okay. And you show it to people who are into sports, right? Or if it's healthcare, you show it. If it's a radiology report, you show it to radiology, right? If it's a legal precedent, you show it to lawyers in that specific space. And you tell them which one do you prefer. Sometimes you can give them more guidance. So which one do you prefer in terms of relevance? Which one do you prefer in terms of writing style? Which one do you prefer in terms of actuality? And for those, you get fairly consistent answers. Of course, it's more expensive to do because you need experts, right? And you need to, they only look at two specific things. But this does seem to work in those cases. If you do it well, of course, on a large enough sample in a really blind way, um, that does work. Otherwise, you have to really degrade to doing multiple choice, which has its own issues. Let's see. Yes, the point says, yes, it all depends on the use case. Yeah, there are different evaluations for RAG, for agentic. Usually what I focused here is kind of the end system, right? So you come say, let's say I do, I extract key metrics from SEC filings in a finance space. Um, Usually the system, it may be, no, I don't just take the PDF, put in an LLM and ask a question. Maybe I have a RAG. I have some, visual language model. I split the document. I extract tables. I have some business logic. Then I answer. Usually what you would test kind of the end system, right? So the end system, look, I send you a question, you give me an answer, I evaluate that answer on the whole system, right? So it's not just the LLM, it's the LLM plus RAG, plus guardrails, plus agent, plus whatever you had there. Model trained on the sensitive topics, obtaining unbiased responses is important. Let's see. Okay. So there's a question here about bias and whether continuous fine-tuning is required. I would say sometimes it is, mostly because you uncover we're still at a point where we uncover new types of biases and new types of attacks. But a lot of it you can do before you go to production first, because we do know what are the common biases against people, against patients, and what are the common cognitive biases. We don't know them because we know a lot about LLMs, because LLMs are only 3 years old. But we know them because we studied people a lot, right? And so medicine is one of those areas where medical ethics, medical decision making has been heavily, heavily studied, right? So some of the first studies, for example, about the impact of groupthink, right, or social situation are from the 19th century. Okay, so the papers from the late 19th century that says, okay, if I'm a doctor and you ask me, oh, here's this patient, what do you think is wrong with them? I would answer differently whether, it's you and me, just talking at lunch, or whether, oh, this is the chief of residence, please tell him what you think, right? Because all of us, we speak differently depending on the social situation, who else is in the room, for example, right? All of us have this tendency, we have this sunk cost fallacy, right? If I already decided this patient has this, I'm less likely to change my mind than if I start from scratch, even if there's mounting evidence that I was wrong. Okay, so people need much more evidence to admit they were wrong than to make kind of the right decision to begin with. I would say very often you can know what those biases are, at least in medicine, in finance, and you can do this in advance. So it's not that you learn as you go in terms of fine tuning. The continuous fine tuning is more, if you launch into new territories, if you serve new populations, right? And then really, you monitor on production, you'll see issues and you need to fix them. See if there are other questions here. Yes, and you don't really get confusion matrices here because we don't have exact numbers. Yeah, I would say one other thing I would add is every domain has its own very specific biases. There's kind of the classic social biases: gender, race, ethnicity, age. But for example, another one that you see a lot in business is basically rich versus poor people. So there are very well-known cases, in finance, if you look like you have more money, or sound like you have more money, we will sell you more expensive services, basically. It's the same thing in healthcare. There was, very recent papers on bias, and it comes and say, oh, a lot of frontier and LM, they do a lot of work on race, right? Because that's, when they have an issue, it's in the papers. But if you look like you have rich patients, they're going to send it to much more, many more screenings and more expensive ones, for example. So those issues are still there. So the other thing I would say about bias is that you should expand your definition of bias, basically from kind of the classic fields to really everything else that really impacts real world decisions. I think that covers the questions we have here. Yeah. Okay, and any other questions? You can find me on LinkedIn. I'm always happy to answer. Or really, if there's something you disagree here, please reach out to me. I'm looking forward to learn more as well.
Perfect. Thank you, David, for presentation. Thank you for everyone. for participating and engaging. So it was a great presentation. It was very great informative of the recent topics. I think it will be on the YouTube, and you guys can watch it. I think if you need to see the slides, I think YouTube will be there. I will talk to our team where to share with the people who are registered for the program. So hope to see you in our future events. We share again a conference link in LinkedIn and November 12th, the next one. Hope to see you in person in that event. Thank you, David, again. It was a great presentation. I hope to see more of your work in future.
Thank you. And thanks everyone for taking the time and listening.
Thank you. Have a good day.